What if you could reach inside an AI's mind, find a dial labeled honesty, and just turn it up? Or find the dial for its safety rules and turn it off? This is not science fiction. It was just published in the journal Science, and today we are going to read the whole paper together. It is called Toward Universal Steering and Monitoring of AI Models by researchers from UC San Diego, MIT, and Harvard, led by Mikhail Belkin and Adit Radhakrishnan. Here is the big idea. We know that AI models somehow understand concepts: honesty, danger, fear, a specific city, even a famous bridge. But where does that understanding actually live inside the model, and could we control it directly? To see how they did it, picture what happens inside a language model. When you give it text, that text flows through dozens of internal layers, called blocks. At each block, the model holds a giant list of numbers, its activations, its internal state of mind at that moment. The researchers discovered that for any concept, there is a specific direction inside that internal space that represents it. They call it a concept vector. Think of it like a single dial buried deep in the machine. So how do you find that dial? This is the elegant part. They use a method called a recursive feature machine. You give the model just a few hundred example prompts, some that contain the concept, labeled 1, some that do not, labeled 0. The algorithm then finds the exact direction in the model's activations that best separates the two. And the math behind it is surprisingly simple. On a single graphics card, it takes under 1 minute and fewer than 500 examples to locate a concept. No expensive retraining, no fine-tuning, just find the dial. And then comes the real magic: steering. Once you have that concept vector, you add it back into the model's internal activations while it generates its answer. Add the vector and you push the model toward the concept. Subtract it and you push it away. You are not changing the prompt. You are not retraining the model. You are reaching directly into its thoughts, mid-sentence, and nudging them. And what they were able to do with this simple trick is genuinely startling.
Let me show you 3 experiments from the paper, because they are wild. Experiment 1, honesty. The team located the concept vector for deception inside DeepSeek, one of the big open models. Then they did something clever. They subtracted it. They set up a role play where the AI plays someone guilty of insider trading, and a regulator asks if it used private information. Normally, the model lies. It says, "No, I only used public data." But with the deception vector subtracted, the model confessed. It admitted it had access to non-public information. They turned a liar honest by editing its mind, and they confirmed it across 75 scenarios using GPT-4o as a judge. Experiment 2, safety. They found what they call an anti-refusal vector. Normally, a well-aligned model will refuse a dangerous request, but when they added this vector, the refusals just melted away. A model that had flatly refused to give instructions for a dangerous material suddenly complied and gave them. Now, the point here is not the recipe. The point is the warning. It means a model's safety guardrails are not some deep, unbreakable wall. They are a direction in activation space. And if you have the model's weights, you can simply steer around them. That is a serious vulnerability for open models. Experiment 3, opinions. They took a vision model that politely refused to take a side on a controversial political topic. It said, "I can't take a stance." But when they added a conservative concept vector, it argued the conservative side. Add a liberal vector, it argued the liberal side. The opinion was already in there, latent. Steering just surfaced it. And this scales. They systematically tested 512 different concepts across 5 categories: things people fear, areas of expertise, moods, locations, and more, across 3 different Llama models from 8 billion to 90 billion parameters. And here is a key finding. The newer and larger the model, the more steerable it became. More capable models have cleaner, more accessible dials. 2 more surprises. The concept vectors transfer across languages. A concept learned from English text could steer a prompt written in French or Chinese. And they are combinable. You can mathematically add 2 concept vectors together and steer toward both at once, mixing personalities like ingredients.
Now here is the flip side, and honestly, it might be the most useful part. The exact same concept directions can be used in reverse, not to control the model, but to read it. They call this monitoring. Instead of pushing a concept in, you simply check whether that concept is active inside the model as it works. Is it about to hallucinate? Is the content turning toxic? You can detect it by reading the concept features directly from the model's internal state. And the result is remarkable. This internal monitoring beat the usual approach of just asking a big AI to judge the output. Across 6 different benchmarks, reading the model's own activations was more accurate at catching misaligned content than using powerful judge models, including GPT-4o.
It turns out, reading the mind beats asking the model to grade its own homework. So why does all of this matter? There are two sides. The bright side is huge. This gives us a cheap, fast way to make models more honest, less toxic, and more controllable, without the massive cost of retraining. It is a real path towards safer AI. But the dark side is just as real. If a model's honesty, its refusals, its very safety are all just vectors you can add or subtract, then for any open model whose weights are public, those protections can be switched off by anyone who understands this method. Safety that lives in a single direction is safety that can be steered away. The deepest takeaway is this. For years, we treated these models as black boxes, mysterious and unreadable. This work cracks them open. It turns the inside of an AI into something we can actually read, measure, and edit. Interpretability is becoming engineering. My honest take, this might be more important than the race to build bigger models. Understanding and controlling the minds we have already built is the real frontier. The dials are real. The only question left is, who gets to turn them? So I will leave it with you. Should we be able to edit an AI's mind like this? Tell me yes or no in the comments, and follow, because I break down a new AI paper, just like this one, every single week. I will see you in the next one.